Welcome to Information Theory Notes. Uh, Discrete memoryless channels can now be discussed. Discrete means finite or distinct. Memoryless channels are static, which depend on only current input and current output values if fed back. Channels are mediums through which data can transmit. So this is the channel. A channel is linked to its probability. How? Input signal x1 can generate output signal y1, y2 or y3. So a single input signal can be there existing, which can result in output. So basically you have this dependent case in which output is generated due to one of the finite discrete distinct input symbols. So that's the conditional probability formula, and it is called, this is called channel transition probability, and that is the output symbol. Generalizing this and putting it into matrix form, you can put them like this. So probability of having a y given x was at input, y being output, is summarized into a matrix, and this matrix is labeled as channel matrix. So x1 can result in y1, x1 can result in y2, x1 can result in any number of outputs. So that are the conditional probabilities. We also know that all outputs can be summed up to get 1. That is basic probability definition. Now there are some understandings that can be developed, but rather than generalizing in advance, we will start understanding them and then individually in detail each part, and then we will generalize this. So let us go to first channels. What kind of channels are there? Can we can we characterize them? So first, let us call a channel named lossless channel, in which one input is generating outputs and another input is also generating some outputs. We can put that in matrix form like this. Probability of having y given x1 has occurred will be put here. Probability of y2 given x1 has occurred will be put here. Probability of y3 given x1 has occurred is 0, so put here 0. So this is channel matrix. So we are writing the channel matrix of a lossless type channel. The basic identification of lossless channel is that only one non-zero element exists. So in a column there is just one non-zero element, and the drawing is better to remember with associated with its name, and then you can generate this on your own, and then you can derive this understanding that a lossless channel has only one non-zero element in a column. Lossless channel, everything is being spoken out, one to many and one to one. So this drawing will help you remember the name as well as the matrix, and then from the matrix derive this part. Another type of channel is deterministic channel. Channels are mediums which are used to, so you have to determine, you have to listen, keep your ears open, indicative of that. So inputs can produce output. If this drawing is kept in mind, you can again generate this, and from this you can say rows will have single in non-zero elements. So that is a deterministic channel. So how do you populate? How first you remember this, then how do you make a matrix? Channel matrix general format you will remember. I need not show you again. In the initial part of this video I have already shown you the channel matrix. So the conditional probability here is p of y1 due to x1. So that is 1, y1 due to x1. This is p of y2 due to x1. So y1 y2 due to x1 is 0, that's why 0, and then y3 due to x1 again 0. Probability of y1 due to x1 is x2. This row is for x2 is 1. Probability of y2 due to x2 0. y3 due to x2 0. y1 y2 y3 for x3s are only y2 for x3, so that's 1. As per this diagram you can make this, and you should know what are the conditional probabilities generally for a channel matrix, and from here further you can derive the definition of this kind of channel, and it is called a deterministic channel. So you start from here, make this explanation according to the observation, and the channel matrix will get definition, then name is deterministic channel. All these details will be revealed later when we do numericals. So introduction is important. First, there is another channel, noiseless channel, which is a combination of lossless and deterministic channel. If we make this kind of drawing, remember this in our mind, in our heads, then you can make this one out. Y1 due to x1, y2 due to x1, probability of y3 due to x1, probability of y1 due to x2, y1 due to y2 due to x2, y3 due to x2, here y1 due to x3, y2 due to x3, y3 due to x3. So this will help you again know that this is a diagonal matrix. So it has only one element in each row and each column, and these elements are unity. Each row, each column, only one non-zero element, and that has to be unity. So that is noiseless channel. Then an important channel, binary symmetric channel. Here there are two inputs and two outputs. All that can be furnished if you remember this diagram. So if x1 input can produce two outputs with these probabilities, and another x1 value can produce these two outputs. So channel matrix is easy. How will you make channel matrix? You know, probability of conditional probability here will be, channel matrix is nothing but conditional probability matrix, and here the probability of y1 due to x1. So probability due to y1 due to x1 is 1 minus p. Then probability of y2 due to x1 is p. Then probability of y1 due to x2 is p. Probability of y2 due to x2 is 1 minus p. That's how you can make the channel matrix. Better you just remember this drawing and associated name. These details can be found by this. Progressing further. Now, since we have done enough introduction, we can go for a question. So in your Rajasthan Technical University or any other university exams, you will get this kind of question. There will be a channel matrix given to you in this format. Let us say you have to find the channel matrix, you have to find the probability of y1 and y2 when the given probabilities of x1 and x2 are these. Also you have to find the joint probabilities. So what will you do? First, the channel matrix has general definition. It is defined like this, and now from this you can find out these. So probability of y1 due to x1, y1 due to x1 is this. So 0.9 will be here, there it is, and here y2 due to x1, so 0.1. Then similarly here y1 and y2 due to x2, so that is due to x2, 0.2 and 0.8. That is here. So we have got the channel matrix. So you have to remember this. Then y1. How do you find y1? If you are good with probability, you know probability of y1 is simply probability of x1 into probability of y1 given x1 had occurred or y1 happened due to x2. So you sum this up, you fill in the given answer. So px1 is given 0.5, 0.5 is put here, y1 x1 is this, put here, x2 is also given 0.5, you put here, y1 due to x2 is here, you put it here, you get the answer. So either this way you can answer this question, or you can write the matrix. So y is given by this, y can be given by the probability of x's into the matrix, the conditional probability channel matrix, and you just multiply and get all values. So together you will get both answers, y1 and y2 individually you will get inside the matrix if you do general matrix multiplication of all the possible values. One method is this, other method is this. Here you will be doing using basic probability formula, and here you will be using the general matrix to get all possible answers and then picking out the answers that you want. Last question is find the joint probability. Joint probability, how will you get? Again, as I have outlined, there is this basic formula that can be used. So suppose you populate this, you want to find this joint probabilities. So how do you get this? From here you can go here. This is found by this formula. P of x1 y1 is P of x1 into P of y1 given x1 had occurred, and similarly others. Then how will you get this? You need this kind of matrix. So you in a sense decode the actual matrix that you require to multiply to get the answer. So first put up the question that we need these. Second, populate the question with formulas, basic probability formulas. Then determine the matrix that need to be multiplied. That will fetch you this kind of matrix. Then you are at the root level in which given data can be populated. These all are given in the question. You can populate it, fill it, and then just find the answer and then pick the ones that you want. So you want x1 y2, x1 y2 is this one. There you go. This is one way. Other way is also there, that you just do this, do this one to get this one. Okay, you already know that the x1 y2 is given by probability of x1 into probability of y2 given x1 had occurred. So that is the joint probability. You can directly find it individually, or you just find all of them and pick out the ones that you need. This is one example. There is transition probabilities for binary symmetric channel. So this is the general definition, and we can summarize the formulas like this. These are all basic probability formulas now applied to the channel matrix information theory coding. Thank you.